right. Let's go, let's start. This should be less than 40 minutes, so we need to go fast. Let's go, do some. Okay, so I need to like use 2 pointers, sum and compare against the target. So I less than times, go to the end. I plus 1 j, go to the end also, and if nums in I plus nums in j is the target, return the indexes of the position. We good? Cool. Come on, come on. Let's go. Palindrome. So palindrome is like university exercise, just pointer to the right, pointer to the left, and compare against the middle. So since we have a number, we need to convert it to str. String. Now start from 0. There is a small thing here that you don't need to go to the end of the array. You can make it go to the half of it, because you don't need to do those extra comparisons, because we're basically meeting 2 pointers in the middle. So the second pointer is also -1 minus a. Let's start from the end and now compare the pointer. So str, if it is not, return false, and if we reach the end, return true. Cool. Let's go. Roman to int. So this one has a small trick that if you get this, you can solve it really easily. So it's basically, for instance, let's grab this one. If you need to process this, the key is that if you are processing a current value is less than the next value, what you can do is subtract current and sum the next one. What this would do is, for example, in m, it will be, because m is less, is bigger than 100, so I will not do it. But here in cn, what it would do is, since 100 is less than 1000, it will do subtract 100 plus 1000. This will result in summing 100, and the same goes for xc, which is -10 plus 100, and iv, which is -1 plus 5. This will turn some 4. So let's do that really quick. One more thing is that I need a dictionary to check the values, obviously. There we go. One more. There we go. And I need a total. Return total. Let's go. So start from 0. And sum 1 each step, and the current value will be in values as y, and the next value will be in values as y plus 1. Now if there is a next value and the current is less than the next value, then total minus equal current, else total plus equal current. They should do it. Let's go. Come on. Longest common prefix. For this, we're going to use first word as a pivot and check character by character to the others. So first word will be in str0, and we need a new return value, which we're going to return, of course. Now again, first word.length we need to compare character by character. So we need another for j starts from 1 because we don't use the first word, and this j will go till the end of the strings. And now if first word in I is not str's position j character y, return the return value. I can see I made a mistake. There we go. And if we reach here, we need to append the character. So return value plus equal first word, the character of the first word that we are matching. This should work. Perfect. Cool. Let's go. Valid parentheses. So for this we're going to use a stack, and if we are processing an opening, we stack it. If we are processing a closing, we need to check if there is the matching pair in the stack. So we need a small dictionary. Opening there. And the same goes for this. There we go. And we need a stack. Now since we're comparing characters of strings, we will return the stack. Oh yeah, after we finish this, the stack should be empty. So we're going to return the stack after the processing. So stack.length 0. And now if we are processing an opening, so if processing an opening, object.values opening for includes the character, push, stack.push the character. Else we are processing a closure, so get the closure, the closing, and check if it matches. So the last opening should be here, and if last opening is not the opening for character, return false. That should do it. Because if you reach here and the stack is empty, it means the entire string was valid. Every closing has found its matching opening. Merge to sorted list. So this one we are basically going to do is create a dummy list, and since it is already sorted, we'll just process the list. So process the list, handle nulls first, and if both exist, just append, process append. This is the one that has smaller value because they are both order. So this node is not null, or current L2 now is not null. So nulls first. If it is null, process the other one. So tail.next will be current L2 node, breakout, because there is nothing else to process. Current L2 node is null. Current L1 null, and break. Now if both exist, current L1 node is less or equal than current L2 node, because if they are equal, it's the same. What we need to do is advance, in this case, the smaller one, so L1. So tail.next is current L1 node, and current L1 node should be current L1 node.next. The opposite, tail.next, current L2 node, and current L2 node should be current.next. And we need to advance the tail. And after all of this, return the first node, because the first one is the head. And something that I missed. Okay, 1, 2, 3, 4. Should be here, right? Current L1 node dot value. There we go. Yeah, we were comparing nodes. Submit. Good. Remove duplicates. Okay, so here basically we're going to process the array from the start, and we're going to use 2 pointers. So I will be our unique counter pointer, and J will be our explorer. And basically we're going to move it until the element is different from the last unique, and if it is, we just swap it and increase the unique counter. So we're going to do that. So I'm going to write that if current element is different from last unique, move the pointer and swap in that order. So obviously first edge case, return 0, we're going to need this, and we're going to need j equals 1, j equal to the end. So if nums in j is different from nums in I, move the pointer and swap. So move the pointer and then swap. So nums I is in nums j. And after all of this, we need to return the index. No, they want the quantity, so it should be not I plus 1. Cool. Let's go. Remove element. This is kind of the same, but yeah, just it's the same. This copy the element and advance. So again, if nums.length is 0, return 0. This would be our right pointer. And now start from 0 this time, because we need to remove the element, and the 0 could be 1 because they pass us the value here as an argument. And j goes to the end. And if nums j is different than the value that they give us, copy the element and advance the pointer. So nums I becomes nums the other way around. Nums j becomes nums I, and I plus plus. And now we return the index of the first valid position. Should do it. I forgot to instantiate here. I just realized it. There we go. Let's go. So str. So this is like classic C str function. Find the needle in the haystack. So let I equal 0 and I less than haystack length. plus, and we need one to count the characters. So while there is a character, while j is less than the needle dot length, and the needle in j is equal to the haystack int I plus j, we just need to count. And if we are here, we found the entire needle. So if j needle dot length, return I. If we didn't find it, return -1. Cool. I remember there is when I was looking, yeah, we can do not search for the entire haystack, but rather haystack.length minus needle.length, and this should be more a more optimized solution. There you go. Cool. Let's go. Search index position. So this one, since we need a log n runtime complexity, we need to implement binary search. So classic left, right pointer, a middle one, and then check and move to the right or move to the left, depending on where it is the x based on the middle one. So let's just implement the binary search. Left equals 0, and let right equals nums.length -1. Now, no, it's not 4. We don't know how many times we're going to do it. So left is less equal than right. We're going to return the left one. So the mid should be the floor between left plus left plus right divided by 2. And if nums in mid is the target, just return the mid. Yeah, just move the pointer. So if nums in mid is less than target, move the pointer. So mid, left. So left should be mid plus 1. Left should be mid plus 1. Else right should be mid -1. Think we're good? Yes. Let's go. Length of the last word. So this one is quite easy if you think about it like this, but we're going to basically iterate the array from the starting to the end. So if we had something like this, we're going to skip the spaces and count strings until we find the first space, and that's it. So it's quite simple actually. Let I will be s.length -1 because we're starting from the end, and the count will be 0. Now, well, there is something to check, and s in I is equal to a space. Move the pointer. Well, it's not space, count, and move the pointer. I forgot to close the parentheses there. Now return the count. Perfect. Let's keep going. Need to hurry up there. +1. So here is implement the carry sum. So the carry sum will be wherever is 9 goes to 0, and if it is an x, just x plus 1. And there is an edge case that is like this. You need to push a 0 from the starting position. So I is digits dot length and -1, because we need to go to the end. I plus yeah, from 0. And now if, as I said, x plus 1, so if digits in I is less than 9, basically we increase whatever digit is here and return. If we reach here, then this becomes 0 because it's not 9, basically. It's not 8, it's 9, sorry. And if you're here, basically we are in a carry, because otherwise it will return from here. So digits and shift 1 and return digits. We could also do 1 and digits, but this is like slower in space complexity because it will like copy the entire array. What did I forget? I is digits plus 1. Yeah, out of memory, so basically I messed up a pointer here. I is digits length minus 1. Yeah, there we go. When you have out of memory, basically you screwed a pointer in a for. Add binary. So this is the hardest one actually. This is implement binary carry sum. Basically sum A, B, and previous carry into the sum, and then calculate the result and calculate the carry. The result will always be the sum rest2 plus the previous result, because we're using strings here. And the carry mod.floor of sum divided by 2. Classic carry. And we need 2 pointers, one for A and one for B. So let I be A.length minus 1, let J will be B.length minus 1, and carry, and the result, which we are going to return because we're going to iterate on it. Well, there is something to process in I or J or carry. We are going to initialize the sum with the carry, and now sum A, and then sum B, and then calculate result, and then calculate carry. So sum A will be if I is 0, basically sum plus equal number of this should be an A, right? Yeah, A, I, and decrease the I. Same for B. Can we copy this? So if J, whoops, J, B, J, and decrease J, and that's it. Result, as I said, result will be sum 2, because we need to construct it right with the previous result, and the carry will be floor of sum divided by 2. I think this should work. Perfect. Let's go check. Cool. Square root. So square root, it's one of 2 options: Newton's method or binary search. I'm not going to do Newton's method because I don't know how to explain it. I don't remember it. So binary search, let's go. So edge case first, left pointer. The right pointer we can do like this, and yeah, answer 0, and while there is a left pointer, there we go, return the answer. And yeah, again, mid, check, and compare. So mid, it should be math.floor of left plus right divided by 2. Check. Check would be if mid times mid, let's do this properly, is equal to x, return the mid, and if mid plus mid should have pointed that created into another variable, by the way. Yeah, answer, this could be a possible answer, and left is mid plus 1, and otherwise right is mid minus 1. Classic binary search. I think I didn't mess it up. Looks good. Cool. Let's go. Climbing stairs. So this one is like if there is one step, answer is 1. If there is 2, it's either 1, 1 or 2. So answer is 2. 3 is like this 1, 2 or 2, 1 and so on. So this is Fibonacci. I just implemented because I don't have much time. So how to implement Fibonacci? And let's just return the n. If we have 2 steps before, we have 1. And if we have if we are 1 step before, we have 2 options. So starting from 3 and on, we go until n, and yep, we will always return 1 step before, and now current ways should be 1 step before plus 2 steps before, and shift steps towards right. So 2 steps before becomes 1 step before, and 1 step before becomes current ways. Let's go. Removing duplicates. So this is basically implement skip. Basically iterate the list and update the pointers. So this is quite easy actually. If there is not a head, oh gosh, if I can type, there, return the head. Current is the head, and while there is a current and current dot next, we will always return the head. So if current dot value is the same of current dot next dot value, we need to do current dot next equals to current dot next dot next. So update the pointer, and now current is current dot next. There. Cool. Merge sorted array. So this one is quite tricky, but I found the easiest solution to implement is basically having 3 pointers. So we will have something like this: 1, 2, 3, and 0, 0, 0, and then we have 2, I don't know, 2, 5, 6. So the 2 pointers will be I, which will be pointing to the last element of nums 1, and j, which will be the pointing to the last element of nums 2, and then k, which will point to the last valid element of nums 1. So basically what I'm going to do is I'm going to write this. If nums 1 in I is bigger than nums2 in j, swap with k and decrease the swapping pointer. This will make sense in a while. So I in -1 should be here, and let j be in n -1, and let k be in m plus n, and the positions -1. So this is the last position of num1. While j, so the second pointer, the second array pointer, exists basically, has not finished processing. Swap. So if there is something to process, to swap, sorry, and nums1 in I is bigger than nums2 in j, swap and decrease the swapping pointer. So nums1 in k should be nums1 in I, and decrease the swapping pointer. So in this case is I. Else nums1 in k will be nums2 sorry, in j, and decrease the swapping pointer. And yeah, after processing, decrease the right pointer. This one took a while for me to figure out and actually understand it correctly because it had 3 pointers moving. Binary 3 in order traversal. So binary 3 in order should be left, node, right. And we're going to implement it using a stack, not recursive. So basically the way that it's going to work is move to the left as far as possible, stacking nodes. Then we're going to visit the nodes and move to the right. So the result is going to be a list, and we're going to have a stack, and current will be root. While current is not null, or stack.length is bigger than 0, we're going to return the result, obviously. Move to the left, visit node, and move to the right. So move to the left as far as possible. So it's while current is not null, stack current and stack.push the current node and update it. So current.left. If we're here, we just push the node, so current will be stack.pop and result.push current.value, and move to the right. Should work. Nice. Same tree. So here we're going to focus on terminating conditions, which are going to be both nodes are the same. One is null and the other is not, and both have different values. And then visit the subtrees because we're going to use recursion. So both nodes are the same. So if P is null and Q is null, they are the same. If one is null and the other is not null, so P is null or Q is null, one of them got filtered out by the previous condition, return the false. And if both have different values, so if p.val is not q.val, return false. And now visit subtrees. So return is same tree, p.left, q.left, and is same tree, p.right, q.right. This should work. Otherwise it will be like a heap overflow, stack overflow. because that's how recursion goes. Last one, symmetric tree. Let's go. So for this, we're going to need a function, which is going to be isMirror, which is going to receive the two nodes. And again, termination conditions. So if A is null, B is null, return true. If A dot no A is null or V is null, return false. And the value. So if A dot value is not V dot value, just return false. And the trick here is that we need to visit them, the subtrees, but swapped. So return is mirror, but A left with B right, because A left with B right. And is mirror A right with V left. And if I did it all correctly, root left with root right. Ooh. Well, hope you like it. Hope I make it. So, thanks for everything.